A summary of the area of a plane region, Riemann sum and definite integral. Consider the curve y equals f of x and lines at x equals a and x equals b. A region R is then bounded by the x-axis, the two lines, and the curve. What is the area of the region R? Divide the bounded region into any number of rectangles or subintervals. For this example, I'm going to use 9 rectangles. Let x0 equals a and x9 equals b. x1 to x8 are the intermediate points between a and b. Let the length of the first subinterval be delta 1x equals x1 minus x0. Delta is the triangle you can see. It's a Greek letter. A set of all such intervals is called a partition. Since delta 5x is the longest subinterval of the partition, its length is called the norm, or standard length of the partition. Let us choose a point in each rectangle of the partition delta. Let it be psi 1. And on top is a point on the curve which has the coordinate psi 1, f of psi 1. Let this be the case for other rectangles or subintervals. Let's consider this rectangular element. An area of a rectangle is height times width. The height of this rectangle and delta x as the width. Now if we sum up all the area of all 9 rectangles, we will have this expression. Or it's just the summation of the product of f of psi I and delta I x, where I is from 1 to 9. And this is just the Riemann sum. In general form, given with n rectangles or subintervals, the Riemann sum is a definite integral of f if the limit a to b exists. And so we are able to solve for the area of the region R.